I audible?
Yes, sir.
Screen share is visible. Screen share. Amit, mute ಮಾಡ್ಕೊಳ್ಳಿ. Amit.
Yes, sir.
Amit, mute ಮಾಡ್ಕೊಳ್ಳಿ. Okay. Can you see the screen share? Screen share is visible.
Yes, sir.
Okay. Now today we shall discuss some more problems on centroid. Now the problem is locate the centroid of the figure as shown here. So you have a T section set in the form of T, and here this width is 100 mm and this is 10 mm, and this height is 60 mm and this width is 10 mm. So first you have to select the reference axis towards the extreme left, and which x-axis touches the bottommost portion of the figure. So select the reference axis first. Next you divide the figure into two parts. So this is part 1 and this is figure 2. Now you calculate the areas of these individual figures. A1, so 60 into 10, so it works out to be 600 millimeters square, and A2 is 100 divided into 10, it is 1000 millimeters square. So sigma A works out to be 1600 millimeters square. Now you can see that this figure is symmetrical about y-axis, because if you pass the y0 axis and x0 axis, so this figure is symmetrical about y-axis, and hence directly you can find the x bar value. X bar will be equal to 50 millimeters. So since the figure is symmetrical about y-axis, so x bar is 50 millimeter. So since the figure is symmetrical, so hence x bar you can omit the one step. So directly you can find out the values of x bar, and y bar we have to find out. So y1. So y1 is, so this is figure 1. So from this point to the center of this figure, that is, this is y1. From this center of this figure to x-axis, that is y1. So since this is 60, so 60 by 2 it is 30 mm. And similarly y2 is the center of, from the center of this figure to x-axis, it is 60 plus 10 by 2, that is 65 millimeters. So if we know the equation, ay bar is equal to a1y1 plus a2y2 plus a3y3 or an divided by sigma a. So hence y bar is equal to, it works out to be 51.875 millimeters. So now you can see here, from this point to, this is the centroid of the whole figure, So x bar is 50 millimeter, and y bar is 51.875 millimeter. So next we shall discuss one more problem. Here you have a figure, it is in the form of Z shape, and this width is 50 millimeters, and this is 100 millimeters, and this depth is 10 millimeters, and from here to here it is 80 millimeters, and this width is also 10 millimeter, and this width is also 10 millimeter. So first what you have to do is select the reference axis which touches the extreme left of the figure and the bottommost part of the figure. You can see here, so this is y-axis and this is x-axis, and here you divide the figure into three parts. It is, so I have taken this as 1 and this as 2 and this as 3. So you can divide in your convenient way. So whether you can divide like this also. So this will become 1 and this whole will become 2 and this will become 3. Now, so this is the reference axis x and y, and x1 is nothing but from the center of this figure to y-axis. So this is x1, and from the center of this figure to y-axis, this is x2, and from the center of this figure to y-axis, this is x3. Similarly, from the center of this figure to x-axis, this is y1, and from the center of this figure to x-axis, this is y2, and from the center of this figure to x-axis, this is y3. So these are the corresponding x1, x2, x3, y1, y2, y3. So first calculate the areas of this individual figure. So a1 is 50 into 10, that is 500 millimeters square, and A2 is 70 into 10. So this total height is 80. So if you take out 10, so the remaining is 70. So 70 into 10 is 700 millimeters square, and A3 is 100 into 10,000 millimeters square. So sigma A happens to be 2,200 millimeters square. So now you can find the values of x1, x2, x3, y1, y2, y2, y3. So x1 from this point to this center of this figure. So this is 50 millimeters. So half of which is 25 millimeters. 25 millimeters. So x2 is measured from this point to y-axis. So this is 50, right? This is total is 50. So that means this is 40. Because if you take out 10, so the remaining from this point to this point, it is 40. And half of this width, that is 5 millimeters. So 40 plus 10 by 2. You can see here, 40 plus 10 by 2. So it is 45 millimeters. So x3 is from this point to this point. So this total length is 100. So half of which is 50 millimeters plus 40. From this point to this point, it is 40 millimeters. So 40 plus 100 by 2. So it is 90 millimeters. So similarly, you find y1. So from the center of this figure to this height, y-axis, that is 80. So this total height is 80, and this is 10 by 2. So that is 80 plus 10 by 2. It works out to be 85 millimeters. So next y2 is from this point to x-axis. That is, so this total is 80. So this is 70. 70 plus, correct? This is 70. This is 10. So 10 plus 70 by 2. That is 35. That is 45 millimeters. So you can see here 10 plus 70 by 2. It works out to be 45 millimeters. And similarly y3. Y3 is from this point to x-axis. So this height is 10 millimeters. So half of this is 5 millimeters. So we have A1, A2, A3, X1, X2, X3, and similarly y1, y2, y3. So now we know the equation. X bar is equal to A1, X1 plus A2, X2 plus A3, X3 divided by sigma A. Similarly, y bar is A1, Y1 plus A2, Y2 plus A3, Y3 divided by sigma A. So on simplification, you get the values of X bar as 60.90 millimeters and Y bar as 35.90 millimeters. So that is, so this might be the center of this figure through which the x0 axis and y0 axis passes. So the x bar works out to be, it is about 60.90 and y bar is 35.90 mm. So is it clear? Any doubts with this problem? Anyone? Shall I proceed with the next one? Hello?
Yes, sir.
Fine. So next again, you have one more figure. Locate the center of the figure as shown. So here you have a figure, so which is in the form of C section, and this is 50, and this height is 10 millimeters, and this depth is 70 millimeters, and this side the width is 100 millimeters, and the height is 10 millimeters. So first, what you have to do is, so this width is also 10 millimeters. So it is in the form of C section. So first you select the reference axis. So this is X and Y axis, and you divide the figure into three parts. So I have taken this pole as 1, this pole as 1, and this as 2, and this as 3. So these are the corresponding values of x1, x2, x3. So x1 is from the center of this figure to y-axis, x1, and from the center of this figure to y-axis, this distance is x2, and from the center of this figure to y-axis, this is x3. So similarly, from the center of this figure to x-axis, it is y1, and from the center of this figure to y-x-axis, it is y2, and from the center of this figure with respect to x-axis, it is y3. So first you find out the areas of the individual figures. So A1 works out to be 100 into 10, 1000 millimeters square, and A2 is 70 into 10, 700 millimeters square, and A3 is 50 into 10, that is 500 millimeters square. So sigma A works out to be 2200 millimeters square. Now x1 is 100 divided by 2. So this width is 100, half of which is 100 divided by 2, 50 millimeters. So x2 is 10 divided by 2, so that is 5 millimeters. And x3 is 50 divided by 2, 25 millimeters. So similarly, y1 is from the center of this figure to x-axis, it is 5 mm. And from the center of this figure to x-axis, it is 70 by 2 plus 10, that is 45 millimeters. And from the center of this figure to x-axis, it is 70 plus 10, 80 plus 10 by 2, that is 85 millimeters. You can see here, A1 is 100 into 10,000, and sigma A works out to be 2,200 millimeters square. And these are the coordinate distances with respect to y-axis and x-axis. So x1 is 50, x2 is 5 mm, x3 is 25 mm, y1 is 5, y2 is 45 mm, and y3 is 85 mm. So we know that x bar and y bar equations. So on substitution, you get the values of x bar as 30 millimeters and y bar as 35.90 millimeters. So this is the center of the whole figure, that is G, through which the x0 and y0 axis passes. So the x bar from this y0 to y axis, it is x bar is 30 millimeters. It is from this point to this point, it is 30 millimeters, and y bar is this height, that is from y0 axis to, sorry, x0 axis to axis, it is works out to be 35.90 millimeters. So these are the very simple problems. So wherein you can find the center of the given figure. Now, last class we have discussed these problems, correct? The L-shaped problem and also the I section, so which is symmetrical to y-axis, and also we have discussed this problem. So again, we shall go through this problem because here you have two semicircles of radius 60 millimeters and 30 millimeters respectively. So first you have to select the reference axis x and y. Then you calculate the corresponding areas of these individual figures 1 and 2. So this is 1, this is 2. So A1 is pi r1 square divided by 2 and A2 is pi r2 square by 2. So these are the corresponding areas. So you'll get the value of sigma A as 7.07 into 10 power 3 millimeters square. Now you want to find the values of x1. Now these are the, you can see here G1 and G2 are the centers of these individual semicircle. So from this point to this point, this is x1, correct? This is x1, and from this point to y-axis, this horizontal distance is x2. So x1 is, so now this is the radius of the semicircle, it is 60. So this height, so the center of the semicircle with respect to base is 4r by 3 pi. So this distance is 4r by 3 pi. So hence you want this x1. x1 is nothing but r minus 4r by 3 pi. You can see here x1 is r1 minus 4r1 by 3 pi, that is 60 minus 4 into 60 divided by 3 pi. And x2 is from this point to this point, correct? So this is nothing but the radius of this circle plus the center of the semicircle with respect to base is 4r by 3 pi. So here it is 60 plus 4r2 by 3 pi. You can see here x2 is r1. r1 is nothing but the radius of this circle, 60 plus this distance is 4r by 3 pi. So we'll get the values of x1 and x2. Now you know the equation, x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2. So on simplification, we'll get the value of x bar as 42.2 millimeters. So now you want the y1, correct? y1 is nothing but it is from this point, the center of this semicircle to x-axis, and similarly this is from the center of this semicircle to x-axis. So which is nothing but the radius of these individual semicircles. That is y1 is 60 millimeters and y2 is 30 millimeters. You can see here y1 is 60 millimeters and y2 is 30 millimeters. you know the areas, corresponding areas. So thereby you'll get the value of y bar as 54.54 millimeters. So this is the geometric center of the figure through which x naught and y naught axis passes. So y bar is 54 millimeters and x bar is 42.2 millimeters. Now let us discuss one more problem. Here, find the location of centroid of the planar area as shown in figure. Now here you have a triangle. You have a triangle and you have a quarter circle. So this triangle, this base width is 30 millimeters and the height is nothing but the radius of the quarter circle. So this is 60 millimeters and the radius of the quarter circle is 60 millimeters. So now these are the corresponding centroid of the individual figures. So G1 and G2. So we know that the centroid of a triangle measured with respect to base is h by 3 and with respect to apex it is 2h by 3. Similarly, if you consider the base, the centroid of the triangle along the base, it is b by 3 and from the apex it is 2b by 3. And the quarter circle, the centroid of a quarter circle with respect to x and y axis is both 4r by 3 pi. So we have derived the centroid of a quarter circle by method of integration. So with respect to x and y axis, the centroid of the quarter circle remains same, that is 4r by 3 pi. Now you can see this figure. First, you have to select the reference axis x and y. Now these are the geometric centers, individual centroid of this figure. And you can see here, x1 is nothing but it is the distance from this point to y-axis, and similarly x2 is the distance from this point to y-axis, and similarly y1 is from this point to x-axis, and y2 is nothing but from this point to x-axis. Now first select the reference axis x and y, then you can calculate the individual areas. A1 is half into base into height. So consider the area of the triangle. The base is 30 millimeters and the height is 60. So half into base into height, it works out to be 900 millimeters square. So here you have to write the units. Here it is missing. It is only 900 mm. So it is 900 millimeters square. And A2 is nothing but the area of the quarter circle, that is pi r square by 4. So it is 2827.4 millimeters square. So then you can find out the sigma A. Sigma A is nothing but A1 plus A2. Now you have to find the coordinate distances, that is x1, x2, y1, y2. Now x1 is measured from the center of this figure to y-axis. From the center of this figure to y-axis. Now you can see here the centroid of the triangle. So if you consider this as a base, it is at a distance b by 3 from the base and 2b by 3 from the apex, or 2h from the apex and h by 3 from the base. So we want this distance. So if you consider this as apex, it is at a distance 2h by 3. So this side it is 30 millimeters. So 2h by 3, 2 into 30 by 3, it works out to be 20 millimeters. So similarly, we want x2. X2 is from this point to y-axis. So which is nothing but x1 plus 4r by 3 pi. Because the center of the quarter circle with respect to either with respect to x or y-axis is 4r by 3 pi. Hence, x2 is 30 plus 4r by 3 pi. So it works out to be 55.5 millimeters. So similarly, we have to find y1 and y2. So y1 is nothing but it is measured with respect to this point, from this point to this height. So if you consider this height, this is 60 millimeter, and the centroidal distance of the triangle along its height, it is h by 3 from the base and 2h by 3 from the apex. So hence y1 is nothing but 2h by 3, that is 2 into 60 by 3, it works out to be 40 millimeters. So similarly y2 is this height. We want this height, but the centroid of the quarter circle with respect to this axis, it is this height is the centroidal distance is 4r by 3 pi. So we want this. This is y2. So y2 is nothing but the radius of the semicircle, sorry, quarter circle minus 4r by 3 pi. So I want this height. So hence y2 is r, that is the radius of the quarter circle minus 4r by 3 pi. So that works out to be 34.5 millimeters. So you have the values of a1, a2, x1, x2, y1, y2. So then you know the equation x bar is equal to a1 x1 plus a2 x2 plus a1 plus a2. So hence the x bar value works out to be 46.9 millimeters. So similarly, you can calculate the value of y bar. It works out to be 35.8 millimeters. So that means, so here somewhere here it is the centroid of the whole figure through which x naught and y naught axis passes. So the x bar value is, it is about 46.9 millimeters. So somewhere it lies somewhere here. Y bar is, it is about 35.8 millimeters. So here you may have the centroid of the whole figure. So have you understood this? Any doubts with this problem? Anyone? ಯಾರಾದರೂ doubts ಇದ್ರೆ don't hesitate to ask the doubts. Is it clear? I hope. So I want any response from you guys. Is it clear? Shall I proceed with the next one?
Yes, sir.
Okay, fine. Now, here you have a typical problem. Here it's a composite section. Now you can see here, you have a rectangle, you have an equilateral triangle, and you have a semicircle. And inside this rectangle, you have a circle. Now you need to find the geometric center of this figure. That is G. You can see this point. This is G through which x naught and y naught axis passes. So we need to find the geometric center of this figure. Now what do you observe from this figure? If you observe, this figure is symmetrical about x-axis, correct? On both sides, you have the mirror image. So here, the given figure is symmetrical about x-axis, hence directly y bar value you can get it. So no need to calculate y1, y2, and y3 because the figure is symmetrical about x-axis, hence the value of y bar is 20 millimeters because nothing but the radius of this semicircle. So this diameter is 40 millimeter. So the center of which is 20 millimeter because the figure is symmetrical about x-axis, hence the y bar is 20 millimeter. Now, so in this problem, you have to locate the center of the given figure. Now here, you have a rectangle here, you have a semicircle, and you have a equilateral triangle, and inside this rectangle, you have a circle. Now you have to deduct this. Circle. That means you have to take out this circle from the entire composite figure, and find out the geometric center of this figure. So you have to deduct this circle from the entire figure because it is within this rectangle. So now your equation. So here already you know the value of y bar because the figure is symmetrical about x-axis. Directly you can get the value of y bar. But x bar you need to calculate what is the value of x bar. So here you divide the figure into 4 parts. That is semicircle as 1, and this whole rectangle as 2, and this circle as 3, and this triangle as 4. So now you find out the corresponding areas of this individual figure. So A1 is nothing but the area of the semicircle, that is pi r square by 2, that is pi into 20 square by 2, and A2 is, it is the area of this rectangle, that is 50 millimeters, and this is 40 because this is radius, the diameter is 40. So it is 50 into 40, that is 2000 millimeters square, and the area of this triangle, half into base into height. You can see here, areas are given here, half into base into height. You can find out this angle. But here, you have to deduct this circle from the given figure. You have to deduct this circle from the given figure. That means the equation for x bar is a1 x1 plus a2 x2 minus a3 x3, because you have to deduct this circle from the given figure. That is, x bar is equal to a1 x1 plus a2 x2 minus a3 x3 plus a4 x4 divided by a1 plus a2 minus a3 plus a4. Got it? Because you need to deduct this. Now let us find the values of x1, x2, x3, x4. Now x1 is from this point, from G1 to y-axis. So this is x1. Now we want this distance, but you know the radius is 20 millimeters. From this point to this point it is 20. So we want this distance. So hence the centroidal distance of the semicircle with respect to base is 4r by 3 pi. So x1 is 20 minus 4r by 3 pi. That is r minus 4r by 3 pi. That is 20 minus 4r by 3 pi. It works out to be 11.5 millimeter. Now x2 is from this center, from the center of this rectangle to x-axis. So which is nothing but 20 plus 50 by 2. Correct? R plus 50 by 2, it works out to be 45 millimeters. So x3 is also 45 millimeters. That is the center of this circle. It is also 43 millimeters. And x4 is the distance from G4 to y-axis. That is 20 plus 50. And this height is h by 3 from the base. Right? So x4 is 20 plus 50 plus h is how much? Here, this is 30 by 3. It works out to be 80 millimeters. So since the figure is symmetrical about x-axis, directly you got the value of y bar, and we want to find the values of x bar. Now x bar, this is the basic equation, a1 x1 plus a2 x2 minus a3 x3 plus a4 x4 divided by a1, sigma a is nothing but a1 plus a2 plus a1 plus a2 minus a3 plus a4. That is the value of sigma a, because you have to take out that area of this circle. So x bar, that is a1, that is pi r square by 2 into x1 is 11.5 plus a2 is 50 into 40 into x2 is 45 millimeters. Now you can see here we have a minus sign here, that is the area of this circle, that is pi r square into x3 is 45 millimeters plus the area of the triangle, half into base into height, multiplied by the value of x4 divided by sigma a. So especially in sigma a, while finding out sigma a is nothing but a1 plus a2 minus a3 plus a4. So on simplification, we'll get the value of x bar as 45 millimeter, and already y bar value, you already know it because the given figure is symmetrical about x-axis. So anyway, so I'll continue the class on Tuesday. So today I will be ending the session. Please mark your attendance in the chat box. So any doubts with finding out the values of x1 and x2? Anyone? You can ask freely, or else I will call your name. Likit Kumar, yes? Are you there?
Yes, sir.
Is it clear? The concept is clear?
Yes, sir.
I hope it's clear. Nandan, are you there? Mr. Nandan A, EC050. Rekha BS, are you there? Rekha BS.
Sir.
Doubts area another, is it clear?
Yes, sir, clear.
Okay. Sri Hari Kashyap. Sri Hari Kashyap. Can you hear me?
Yes, sir.
Doubts area another,
Yes, sir. I can hear you.
Huh? You have a
ಇಲ್ಲ
doubt?
ಸರ್ ಎಲ್ಲ ಕ್ಲಿಯರ್ ಆಗಿದೆ ಡೌಟ್ಸ್ ಏನು
Okay.
ಇಲ್ಲ
So
ಸರ್ ಕ್ಲಿಯರ್ ಇದೆ
Next class, we shall solve some more problems on centroid. Okay. So, okay.
Okay, sir. Okay.
Thank you so much. Have a nice day. Have a nice Sunday. Stay safe. Stay at home. So again, we shall meet on Tuesday. So till then, have a nice day. Goodbye. Thank you.